Hey guys, this is Vinny, and today I will be explaining two concepts in Unit 3, or functions. Okay, so before we do all this, first we have to see what is a function. A function, at the most basic level, is a rule where one x value, or one input, gives one output, one y value. So the purpose of this is a tool to find patterns and predict how things change. Okay, so first let's look at one-to-one functions. What is a one-to-one function? First, what's a function? Function, for one x value, there can only be one y value. So how do you test if something's a function? This is where the vertical line test comes in. So as I did here, you draw a bunch of lines through the graph, and if it hits more than 1 point, if one of these lines hits more than 1 point, that means that's not a function. Because each x value can only have one y value. Let's say this x value has a point here, then it would be hitting it at 2 points, making this not a function. Okay, so now, what's a one-to-one function? Let me give an example. So, I'm going to draw a graph here. Y equals 3x plus 3. Let's do a really quick graph. Might not be the most perfect graph, but I'm trying my best. Okay, you get the idea. So, in this first plot, 0, 3, 1, 2, 3. Then the slope is 3, so we go down 3, 1. Then it would just keep going. 1, 2, 3, 1. So once I'm done graphing that, now I can check if it's a one-to-one function. So a one-to-one function is no matter what x value it has, like let's say x1, this is just a placeholder, and x1 and 5, or x2 and 5. So if it has these 2 points, that means it's not a one-to-one function, because a y value can only be used once in a one-to-one function. Let's see if this graph here is a one-to-one function. We can test this by first drawing the vertical lines to test if it's a function. I don't see it hitting it twice in any places. So then we're going to draw the horizontal line. If you see it hitting it in any places, hitting it twice, does not hit it twice. Meaning this is a one-to-one function. I'm going to give a quick example of a function that isn't one-to-one. As you can see, it clearly does not pass the horizontal line test because it hits it twice right here and in a lot of other places, meaning that it's not a one-to-one function. So right here, this is a bad graph, but this is an absolute. Okay, no, this is a quadratic. Sorry, I'm drawing I changed my mind. Okay, so this isn't a one-to-one function. It's a function because if you draw your line through it here, it doesn't touch it twice. But if you draw a horizontal line, you can see that it touches it in a lot of places twice. Meaning that, for example, okay, so if the equation is y equals x squared, right? So you know what that means? That means if I plug in 2 squared is 4, and negative 2 squared is also 4. Meaning that it has 2 of the same y values. So it's not a one-to-one function. Now, let's do a quick. Okay, so let's talk about adding and subtracting functions. So I wrote two functions here. F of x equals 5x squared plus 10x plus 15. G of x equals 25x plus 25. Okay, so for the first operation, we're going to do f plus g, this function plus this function. So we'll do 5x squared plus 10x plus 15 plus 25x plus 25. So what does this get us? This is just combining like terms, so it's very easy. 5x squared plus 35x plus 40. That should be it. It's just that easy. Okay, let's move on. Let's do f minus g. Okay, now here's where it gets a little bit more difficult. You have to be a little more careful. So, similar, 5x squared plus 10x plus 15. And then you write the minus here, then parentheses. 25x plus 25. So this would become 5x squared plus 10x plus 15 minus 25x minus 25. You know, that would be 5x squared minus 15x minus 10.